The last three problems are trigonometric. So we have tangent of x squared y to the fourth equals to 3x plus y squared. The derivative of tangent d by dx of tangent of an angle x is just equal to secant square x. Then you differentiate the angle. So the derivative of this tangent is secant square of whatever angle you have, x squared y to the fourth, times the derivative of the angle. So product rule, because you have x and y, so we hold x squared and differentiate y to the fourth. We get 4y cubed, and then we attach y prime, plus we hold y to the fourth and differentiate x squared, we get 2x. So we have already differentiated the angle of this. All equals, derivative of 3x is just 3, and the derivative of y squared is 2y y prime. So we can further simplify. Remember, you are now multiplying this angle by this expression. So we can simplify now. Every term in here, we can multiply it by this expression. So we have the first one, this time this, which is x squared. The 4 is outside, x squared y cubed y prime secant square x squared y to the fourth, and then plus this time this, so it's 2x y to the fourth secant square x squared y to the fourth, all equals to 3 plus 2y y prime. So those terms of y prime, put on one side of the equation. So we bring this 2y y prime on this side. We have 4x squared y cubed y prime. Now we can just factor it out. So it's secant square x squared y to the fourth. We taking this y prime from there is outside, and then this 2y y prime, we'll send it across, it becomes negative, so we just left with 2y. All equals, every other term we must send them on the right hand side. So this is the only term here. We send on the right hand side, it becomes minus 2x y to the fourth secant square x squared y to the fourth. So we must divide both sides now by this expression. So we have y prime now equals minus 2x to the fourth y secant this x y to the fourth secant square x squared y to the fourth, all divided by. So in this, because we are dividing this on both sides, right? So this is y, this is also y. Y is common to the two of them. 2 is also common, so 2y is common. We factor it out. So what is left? You have 2 into 4 2 times. This is x squared y cubed. We took 1 out of it, so it's y squared, and you have secant square of x squared y to the fourth, and then this is just minus 1. So this 2y can cancel this 2y from up there. So finally we can have y prime equals negative x y to the third secant square x squared y to the fourth, all over 2x squared y squared secant square x squared y to the fourth minus 1. Is there a way we can simplify from the problem? Can we simplify from the problem? So we know that tangent square x plus 1 is equal to secant square x. So this is secant square x. Okay, we cannot do anything there. So we just leave it as it is. So let's move to the second to the last problem. Then we solve the last problem on the implicit differentiation. So the essence of these problems is for you to to actually get used to the method of implicit differentiation, as we go ahead under exponential and logarithmic, trigonometric, hyperbolic, we will solve some challenging problems. These are just little ones that you can just play with. So question 11 says 7y squared plus sine of 3x all equals to 12 minus y to the fourth. So we differentiate 2 times 7 is 14y. We attach y prime. We differentiate sine, we get cos of the angle 3x. Then we differentiate the angle. The derivative of 3x is just 3. The derivative of 12 is 0. The derivative of y to the fourth is 4y to the third, right? Then we attach y prime. So our aim now is to solve for y prime. So this is 14y y prime plus, send it across, 4y cubed y prime, or equals, this 3 comes behind, so it's 3, negative 3 cos of 3x. We can now say we just factor out this y prime, so we just have it like this. So we can now divide both sides by 14y plus 4y cubed, 14y plus 4y cubed. So we have y prime to be what? Minus 3 cos of 3x. So we let, it's not really important. We can factor out 2 and y, so it's 2 y. We can factor it out. 2 into 14 7 times, y is already out. 2 into 4 2 times, then y squared. So it's not really important, but we can just do that to simplify the problem. Okay, so that's it for this problem. So let's move to the next one, the last problem. So the last problem says x squared tangent y plus y to the 10th power secant x is equal to 2x. So in this term, we have two functions, x and a trigonometric function. So again, we use the product rule. We hold x squared and differentiate tangent. We get secant square y. Because y is the variable, we differentiate y, we must attach y prime. The derivative of y is just 1, but we must attach y prime. It's the name of this function. Plus, remember we held this x squared first, so we must now hold tangent of y and differentiate x squared to get 2x. Again, we hold this y to the 10th power and differentiate secant. We get secant x tangent x. Plus, we hold secant now and differentiate x, that's it, y to the 10th power, it gives us 10y to the 9th power, and we attach y prime. The derivative of 2x is just equals to 2. So we can now solve for y prime. This term has y prime, and this term has y prime. Must group them. X secant square y prime. So we just group them. They are both on the same side of the equation. So this is y prime. So this expression now is 10y to the 9th power. So it's plus 10y to the 9th power secant of x. And then on the right hand side of the equation, we have 2. We send this term across. Okay, this term and this term. So it becomes 2 plus 2x tangent of y. And this one is minus y to the 10th power secant of x tangent of x. We divide this side and this side by this expression, we have y prime to be 2 minus 2x tangent of y minus y to the 10th power secant of x tangent of x, all divided by this expression, right? So we have x. If you like, you want to factor out secant. You cannot factor out secant, in fact, because you have secant of y and secant of x. So it's x secant square y plus 10y to the 9th power secant of x. So this is actually our final answer. So I want to say thanks ever so much for watching, and please subscribe to our YouTube channel. See you in our next lecture. Thank you.